So as I mentioned, today I'll be taking you through iDesktop training, and what we'll be doing is covering a mini project. It's on multi-hazard mapping in Kenya. So I'll first take you guys through exactly what multi-hazard mapping is. I'll first take you through what multi-hazard mapping is. I'll take you through the data and materials that we'll be using for this particular mini project, and also the methodology and the flowchart, what we'll be doing in iDesktop, the expected results, that is the expected map layout, and also we'll go to the practical, taking you guys through the practical bit on iDesktop. So onto multi-hazard mapping. So for example, what's before even talking about why I chose to do multi-hazard mapping, we have to cover first of all what is a hazard, what is a multi-hazard, what is multi-hazard mapping, and why we can do this. So for a hazard is sort of like a disaster. In this particular case, it would mean cases or events like forest fires, droughts, we have floods, we have droughts. Yeah, I've mentioned droughts. Yeah, so now coming to multi-hazard, that's simply not only looking at one particular hazard type, but many. For example, if I'm talking about multi-hazard mapping, I'm not only going to do drought mapping or flood mapping, I'm going to do all cases of these hazards to be showcased in one map. So in this particular case, I just chose to show you a few pictures of some hazard events that have happened in my country, in Kenya. So for the first photo, that is a mudslide. For the second photo to my left, that is drought. To my right, this is a section of a village that had a flood. And that simply means we even had some of our roads being impassable. So why would one choose to look at multi-hazard mapping? Multi-hazard mapping would aid the planning team in analyzing all the locations that encounter these hazards for susceptibility and risk. And by that, what I basically mean is after we've been able to identify the areas where we have these hazard events happening, we can be able to see which areas would be more prone to having these events happening. So that's basically what we mean by susceptibility and risk. It's the probability of you also having to experience the same hazard. Yeah. So onto the data and materials. I'll be using the Kenya counties shapefile. By Kenya counties, here in Kenya we have quite a number of administrative units. Of course, we have the country as a whole. We then have the second administrative unit is the county, the third, the sub-counties, and so on and so forth. So in this particular case, I'll be looking at the Kenya counties. I'll be having a polygon. In GIS, polygons, we normally have points, lines, and polygons. So points, of course, it's just a point. A line would represent maybe roads or rivers. Polygons are known to represent regions, if it's a building, if it's a lake or whatnot. And the format would be a vector shapefile, and the source is the Humanitarian Data Exchange. So just to show you the Humanitarian Data Exchange, I'll just choose to show you the website. It should be here. Here, let me just open another link. So if at all you're looking to, I know you might be also looking forward to doing your GIS projects for the GIS contest. The Humanitarian Data Exchange is a great place to get any data set that you're looking for. In this particular case, this is actually where I got data for my disaster events. It was as an Excel sheet, but we'll look at this much later. So it's taking time to load. I'll just leave it at that. So this is the link. We also have the Kenya disaster events or the Kenya hazard events. It's simply the distribution of hazard events or disaster events, for example, the floods, droughts, forest fires, mudslides, landslides in Kenya. The format is tabular, and by tabular I mean in an Excel sheet, CSV file. The source was also the Humanitarian Data Exchange. So these are the two data sets that I'll be using to come up with a multi-hazard map for Kenya. So onto the methodology and the flowchart, you'll notice that especially in GIS, for the GIS contest, of course, we have the mapping category as well as the application analysis category, development and the paper group. But in most cases, while looking at GIS, there has to be a methodological flow to your processing. If you're saying you want to come up with a map of, for example, water catchment areas in your country, there has to be a flow from collecting the data that you'd need, the processing in Supermap, then having the final map and then presentation. So that's why I chose to come up with a flowchart, and this is the flowchart. So the first step is on data collection. For data collection, I had mentioned that I got the data from the Humanitarian Data Exchange, that website, and I downloaded it. And I think I had sent it to Yuritsa as well, so I believe you also have these data sets. So on getting data collection, I'll also take that to Supermap. I think I'll explain this methodology once I'm in the software already. But ideally, the expected result or the map we should finally come up with should look like this. So this is a multi-hazard map. I had mentioned that I won't only map out one hazard event or one disaster event. So you see we have our map that showcases, if you look at my legend to my very left, we have the county boundary. This is the counties in Kenya, showcasing the counties in Kenya. We have what this legend signifies, for example, very low, low, moderate, high, very high. It simply shows the risk or or the occurrence of the events in my country. For example, where we have dark green, it means that we have very low occurrences of hazards happening. So it could either be very low or none at all. If you look at this shade of red for very high, it means that we're having very high cases of hazards happening. And to my right, we have just a few details about it and whatnot. So this is the final map that I'm hoping to take you guys through the creation of. And then, of course, so this is a practical. So let me go now to, this is the website, the Humanitarian Data Exchange. So we have varied data sets. So it's a good place to find open source data sets, data that is free for you to use. You can either use those that are of your country or a different country. So this is where I got both data sets, my county shapefiles, as well as my disaster events. So maybe you can look at that later. So if there are no questions, I'll give you about a minute if you have any questions before I start with the project itself, going to iDesktop. Any questions?
No.
No. Okay, good. So let me start the project. You can still see my screen, right?
Yes, we see.
Okay. Okay, so I'm sure you already know, you've already interacted with Supermap to know this is normally the graphical user interface that you'll first get once you open the software. So my first step and what I normally advocate is, number one, under the workspace manager, you can choose to either start saving your workspace as early as now or start bringing in your data sets. Remember, from my, I had already deleted it. From my, let me see, for my presentation, I had showed you that we had two data sets. We had the CSV file. I had my Kenya counties data set as well as my disaster events CSV file. So these are the two data sets that I'll first bring onto the software. So the first thing that I prefer to do is first start by creating a data source, because the purpose of you can't bring in your data sets without having sort of like a place where they'll be kept. So I'll right click my data sources and then select create a new file data source. You can also do it with me on your computers. I'll name mine 02. I already had a 01, so I'll name mine 02, and I should have it displayed. I could equally now start by importing my data sets. You right click for whatever name you've given it, you can right click the data source, then select import your data sets. So in a case where you're not looking to import data sets, but you're looking to create your new data sets, you'd select new data set. But for me, I'm choosing to import data set. So the first thing I want to import is my counties file. How I'll do that is you just click this first. I'm sure you know that. You click this first icon to add file. Then you go to where you had saved the data that Yuritsa had given you. So I have my disaster events and my Kenya boundaries file. For the Kenya boundaries file, let me just go to it. For my Kenya boundaries file, it was a zipped file. So of course you'll unzip that. Just right click and choose to extract all or use another unzipping software. So once you select extract all, you should have this folder. So for my Kenya boundaries file, I'll select the folder. Then you normally have, because for a shape file comprises of a number of separate files. But whatever is read and used in a software, not only for Supermap but other GIS software, is normally this file, this shape source. If you don't have AutoCAD in your computers, it should maybe read SHP or something of the sort. So this is a file that we normally load onto the software. So I'll just select open. I should then see it displayed here. I'll then choose to add the CSV file as well. So, which is here, my disaster events. And then an important thing to note is for my disaster events, we have a tab that sort of shows you what's contained in your data set. So we have various rows, various columns and whatnot and everything. And then an important thing is also I'm using the CSV file in as much as I want to display what's in the CSV file. I don't want it to come onto my software as a CSV file. I want it as a shape file. So Supermap allows us to do that by selecting import spatial data. This is where you select the coordinates from, because I'm sure that my CSV file had the latitude and the longitude. For my longitude, I'll select this longitude column. For my latitude, I'll select this latitude column. So what are longitudes and latitudes? Longitudes and latitudes are simply, they sort of give us, they're actually coordinates. So they specify where the event occurred. So for example, for this particular case, in Luanda, we had it occur at this latitude, this longitude, Kichusuru, this latitude, this longitude, the same thing with Karura Forest. So it helps us, so that means that once I've already said that we should import the spatial data, I will be able to see this data set mapped onto the software. If I choose to only bring in the CSV file without selecting import spatial data, it will come as tabular data, and I don't want that. So I select import spatial data. For the longitude, it's the longitude column. For the latitude, it's the latitude column. Then once I make sure everything is okay and these are the only data sets I needed, I simply click import. Yes, and you should have them under your 02 data source on this side. So we've already done data collection. The next thing we want to do is visualize these data sets, and how I do that is by simply making sure that both data sets are selected. Just drag and drop that onto the map window, and you should have something like this. So any questions so far? Or am I too fast? Are you following?
Yes, we're following. It's okay.
Okay, okay, okay. Right. So once I've already dragged and dropped both data sets and I have it on my map window, one thing you'll notice about Supermap is that once you drop any data set onto the map window, it sets it to full extent. It sort of zooms out and makes sure that you can see everything. So in this particular case, the first thing that I noticed, for those of you who don't know how Kenya looks like, this is how Kenya looks like. This is Kenya. This is my country. That's how it looks like. So, but what you'll notice is I was expecting that once I drag and drop everything, the software would have given this as my full extent, but it didn't. What it did was it gave me this, which simply means that because you can now see what I was saying about the CSV file. You see, we've been able to now map out the location of the hazard events. So now what I need to do is, because if you look closely, in as much as I'm having points on Kenya, but I'm also having points outside Kenya. I'm having this point, I don't know if you can see, I'm having about 1, 2, 3, 4, 5, about 5 points, 5 and a few others roughly outside Kenya here. So that is why I had to come up with this flowchart. So I have data collection. I did data collection. I then brought the data sets onto the software. So the next section is data cleaning. By data cleaning, what we simply mean is, in this particular case, it's the removal of outliers. And outliers simply mean an outlier is a measurement value that is outside of your area of focus, or the value is so far out. So in this particular case, if I go back to my software, these 6 points, this 1, 2, 3, 4, 5, this 5 points that seem to be outside of Kenya are my outliers, because they've in as much as I expected to have all my hazard events in Kenya, so that means we maybe had an error, a human error. Maybe someone didn't write the right latitude or longitude. That's why it's taken me out of my country or something of the sort. So this is where we now do the removal of outliers. And how we do that on Supermap is by using under maps, map clip, you have to select the object area to clip. And the reason why I'm clipping is so that at the end of the day, I'll only have the disaster events that are in Kenya. Because right now I'm having events that are in Kenya, but I'm also having a few other events that are outside Kenya. And I don't want the ones that are outside Kenya. Why? Because I'm only mapping out the hazard events that are in Kenya. So I'll select object area to clip. So it's saying please select one or more regions. So what you do is for your mouse, just left click and drag, then release your mouse. Then it's saying please right click to end. So once I right click my mouse, you should have this tab open. And this is where you'll be clipping your data sets. Now remember, because in as much as it's saying we have the disaster events and my boundaries file, remember what I'm trying to do is clip my disaster events to fit Kenya. I'm not trying to clip my Kenya file. So I can just select the Kenya file and delete for so that I'm left with my disaster events. So this then means that I'll have clipped my disaster events to Kenya. So you just select OK. You should have the process run. And this is the new file. So if I, for example, drag and drop this file so that I can be able to view it, you'll notice, let me just set it to full extent. So initially this was my initial file. If I set that to full extent, this is what I had. If I select the clipped file, if I right click and set it to full extent, this is what I had. And you see this makes more sense. So what we've simply done is I've clipped the disaster events to Kenya. We can then use this next to in the layer manager next to the files. You normally have like the eye icons, so I'll just choose to close it, close the first disaster events, or even delete it. Just right click and delete. Are you sure? Yes, I'm sure. So that I'm now left with this particular hazard events. Now you might be asking, for example, do we always delete the outliers? No, we don't always delete the outliers. In this particular case, the reason why I chose to delete, okay, so number one, we do not delete outliers if they would give you more insight to the data that you're currently using. In that particular case, I mean, for example, if your students, you've done a test, we have students scoring between 70 and 100, but then there's this, we have about 5 students that are scoring 20%. So it doesn't mean that you do away with those students that score 20%. It simply showcases that maybe these students who are scoring 20% need more attention, right? But in this particular case, if I choose to view this data set, for example, the very first data set, if I choose to look at the attribute table, you just right click, browse attribute table. To the very bottom, we have the records, like next to hide system fields, we have the records being 1013, right? If I choose to look at the clipped file, if I choose to look at its attribute table, I have 984 records. That's about more than 20, I think. More than 20 records have been deleted. So, number one, these records were already outside of Kenya. And remember, I'm simply trying to visualize the hazard events that are in Kenya. So, me deleting those records won't mess up my analysis. So that's fine. So the first thing you should note is if you have outliers, you do not always delete them. I've given you an example where you can't delete or do away with outliers. But in my particular case, those about 20 points meant that it wouldn't have an effect on my analysis. Why? Because I'm looking at Kenya. Number two, you'll notice that while looking at my map, I had mentioned that, okay, if I choose to return this, let me full extent. Remember, we had said that just looking at the map, I thought that we only had about 6 points. Six, or if I zoom in closer, I can see about 7, 8, I can see about 8 points. But once we did our clipping, you can see that about 20 points deleted. So what does that mean? So number one, that would mean that we had multiple hazard events occurring at the same station. Okay, so what my eyes see and what the data tells me gives more insight to the data. And I'll repeat this, you'll see me come to this conclusion much later. So I can just delete that tab. I can also delete that tab, and this is what I have. I'll also delete this first data set. Yes. So I'll be left with, I'll be left with this. So we're here. Next, the first thing that we do, so I'm already done with data collection, I'm already done with the removal of outliers. Then, before I even move on to this particular section, and I'll explain why I did this, but before you do that, there's always a rule of thumb in spatial analysis or in mapping that the data sets that you use have to be on the same coordinate system. Coordinate systems are simply systems that are used to sort of, because you know that the earth isn't flat, so we have people who've come up with different coordinate systems for different regions, be it geographic coordinate systems or projected coordinate systems that allow you to do calculations, for example, if it's perimeters or areas, or look at angles. So in this particular case, I need to know which coordinate system. Let me delete this disaster events from my workspace. What can I delete? Close data sets. Yeah. Yes. And before we move on, let's also save our workspace. So I'll save my workspace. Let me change the name to 02. I will save it. The file name, I will save it as 02 as well. Yeah, I'll save it. I had 01, so 02. Yeah, then save. It's always good. It's always a good work ethic to make sure that you go along saving your work. So the next thing is to, I wanted to delete this. Okay, for some reason it's not. Anyway, so number two, the next thing we need to do is check the coordinate system of my datasets. So you might be asking, why would I even consider looking at the coordinate systems? So number one, the coordinate systems are really important because I can assure you, for example, that the coordinate system that Kenya uses may not be the same as the coordinate system that your country uses. So if I'm choosing to do analysis, I have to make sure that all my datasets are in the same coordinate system. If your datasets have different coordinate systems, you might have a scenario whereby you're trying to do a particular analysis, but the function doesn't work because it's saying that it's not able to perform a function on datasets that have different coordinate systems. So how I'll be able to check which coordinate system is which data set has which coordinate system. For example, for my boundaries file, I'll just right click and select properties. Oh wait, I've seen how to delete my data set. Sorry. Yeah, I'll just select it, right click, go to properties. So to the very right, you'll be able to see a tab that shows you the data set, details about the data set, the bounds and whatnot. We have the coordinates. This is where you're checking the coordinate system. In this particular case, we have the coordinate name being the geographic coordinate system, WGS 1984. So this is for the boundaries file. I want to check for my disaster events. So you can just click the disaster events. To my right, I see that it's a planar coordinate system. So of course, number one, I've realized that the data sets are on different coordinate systems. So then the next step is to make them be on the same coordinate system. Normally, we don't really use this planar coordinate system when you're coming up with your final maps. So what I chose to do was make sure that my disaster events file is on the same coordinate system as my boundaries file. And how you'll do that is we have this particular icon where you can choose to research your coordinate system. You just select the drop down arrow, select more, and then this is where you have a number of coordinate systems. Like you have the geographic coordinate system, we have so many. We have the projected coordinate system, we have so many as well. We have customs. By custom, I simply mean you can choose to create your own coordinate system using certain parameters. We also have favorites. Favorites are simply coordinate systems that are mainly used. So how you'll be able to know which coordinate system you want, I had said that I wanted to use for the boundaries file. So we have this coordinate name. So you can just choose to copy that. So I've just selected it and I've copied using Control C, then more. So if you don't know exactly where it is, okay, first of all, it's normally under favorites, but for example, if you don't know where it is, you can just search for it here. So I'll just paste it and you see, I have it here. Then you click apply. So now I'm sure for my Kenya boundaries file, I have the boundary. I don't think I've changed it. Yeah, I didn't change it. So I go back, I change it. Yeah, this one. I apply. So now I'm sure that my boundaries file and my disaster events file have the same coordinate system. From then on, I can move to my next step. My next step is on this particular case. So my next step is to convert my hazard event data to weighted point data. Now, let me explain this, what I mean by this. Now, remember that if when we looked at our attribute table, I said that we have about 984 points, right? But if I look at my map, do you think that these are 900 points? If you look at it, how many points do you think these are? If you look at it just by using your eyes. Anyone? No answer is wrong. No answer is wrong. Anyone? It's okay. So if I look personally, if I look at this map, I don't think these are 984 points. I think they look to be maybe 250, 300, but they couldn't be 984 points. So then that means, why is my data set telling me that if I browse my table, why is my data set telling me that I have 900 points, 984 points, yet I only see a minimum of what, 300. So that simply doubles down to what I had earlier said. Do you remember when we had to clip my map, reduce to remove the outliers? Remember, according to what we saw, I only saw about maybe 9 points, but what was deleted was 20 points. So this simply means that in as much as your eyes can only see, let's say, like 300 points, but the attribute table is telling me I have close to 1,000 points, that means that I'm having hazard events happening at one particular point multiple times. By that I mean, for example, for this particular point, I might be having, because if you have multiple events happening at the same point, it will only be one dot. You can't, we cannot have like some other dots surrounding that area. Like it's only one point. So how you can be able to ascertain if whether your thinking is correct is by doing this step. You're doing some spatial statistics. You're trying to convert the point data, this is a point data, to weighted point data. And what I mean by weighted point data is simply now moving from having an attribute table that shows me 984 points, I want a shapefile that will show me, the attribute table will show me that I have this number of dots, excuse me, that has this number of points, but it's also telling me how many occurrences of hazard events I've had. So maybe it should show me, maybe I'm having 20 occurrences of disaster events happening at one point, or 50. So it's a great way to know why, and to see why there's that difference between 984 and, like, let's say the 300 points. So how you do that is by going to spatial analysis. Under spatial analysis, you go to spatial statistical analysis, go to utilities tools, and collect events. So this particular tool is known as collecting events. And what it simply means is it's trying to collect all the number of points that are happening at one point, then tell you if they're 20, if they're 60, or whatnot. So I'll save mine as collect events, and make sure that the particular data set you're clicking here is the one we had clipped. Then click OK. Oh, let me do it again. I want it as spatial statistical analysis, utilities tools, collect events. I want it as collect events. So I drag and drop, and you'll notice that there's no difference between the collect events and the Kenya disaster events, right? By what your eyes see. But if I look at now my attribute table, you'll see my points have now been reduced to 546, which is it's kind of close to what I saw with my what the estimate that I made with my eyes of less than 300, 400. But you'll notice that I have a new column, and this is the counts column. Let me arrange that in descending. Now, what this data set simply tells me, it tells me that, for example, at this particular point, I had 11 hazard events occurring there. 11. At this point, I had 15 hazard events occurring there. So you're able to see that this now 546 gives a more, it makes sense. It has a more reasonable explanation as to what I'm seeing, as opposed to seeing 984 points. So once I have this, let me just first save my work. Yeah. So once I have this, I can then move on to my next step. So I've already explained why we had to do away with our outliers. I've already explained why we had to do spatial statistics. And you'll notice that even when you're doing your projects, or even when you're coming up with submissions, there has to be sort of like a flow to what you're doing. For example, why are you doing this? Why are you not using this method? Or which one would be the best method to use? The next thing is on coming up with or applying a hotspot analysis technique. So in as much as someone can choose to maybe just present this data as it is, as a map, it wouldn't give more information to the user of the map. So what I thought of is, let's do a hotspot analysis. Let's use a hotspot analysis technique. And in this particular case, it would show the user areas where we have hotspots of hazard events occurring, or cold spot areas. The difference between the two is, For the hotspot areas, it showcases very many hazard events happening. It's highly susceptible to more hazard events occurring. For the cold spot areas, we have low susceptibility or even no occurrence of the hazard events happening. So the next step is applying a hotspot analysis technique, or in this case, interpolation. By interpolation, what I simply mean is, for example, if you look at this data set, I have the points for the hazard events, but I want to create a surface that would have, I sort of need a full continuous surface for a map. For example, what I'm aiming for is what I have here. You'll notice that we were able to convert the points to now showcase a continuous surface, showing us the areas where it's really hot, okay, not really hot, areas where we have high occurrence of these hazards happening, areas where we have low occurrence of these hazards happening. So the technique I chose to use is under spatial analysis, interpolation. I chose to use the inverse distance weighting method. It's a popular interpolation technique that's mainly used for if we're trying to interpolate. By interpolate, what I simply mean is get values for the areas where you do not have the values using the points that you already have. That's called interpolation. So I have the points where hazard events have occurred, but I need to sort of, it's not prediction, but it's sort of, you're aiming to create a smooth surface with measurement values. So in this particular case, the dataset that you'll be using is the collect events dataset. You have to make sure you've selected that. And the field that you'll be using is the counts. Remember, I mentioned that we noticed that our data set is unique in the sense that we're having multiple hazard events happening at the same time. So this counts column is very important in my generation of this particular surface. The next thing is to set my environment. And why I'm choosing to set my environment is, remember I had mentioned that the dataset that the final map that I'll be creating is for Kenya. So I need to set bounds for my map. So for my results bounds, I'll set it as my Kenya boundaries file. For my clipping of bounds, I'll set it also as my Kenya boundaries file. I'll choose to set it as global. By setting as global, it simply means that any analysis that I'll be doing, any raster analysis that I'll be doing in Supermap will only consider Kenya in this particular instance. Like, we'll sort of clip everything to Kenya. So once I set that, I can just click OK. I click next, and I click finished. Great, so this is the file. If I drag and drop it, yes, this is what your map should finally look like. Now, the first thing is I really want to see my boundaries file. So what I'll do is you can just double click that polygon that you see there. To your right, you should be able to see, yeah, it's coming. To your right, you should be able to see some properties for your polygon. I normally select null. Null simply means, okay, let me bring this on top so that you can see what I'm saying. Null simply means you're trying to make the color, okay, not the color, you're trying to make the polygon hollow, meaning that it's transparent. It means that you can be able to see anything that is on mainly on top or below. The next thing I'd like to do is change the line color to black. So just select that, change it to black, and change my width to about 0.5. Yeah, something like that. But of course, this fully depends on you. So once I'm done with this, the next thing is, you'll notice, okay, first of all, I don't like the color, but I'll change that in a minute. Okay, let me change this to 0.4. I think it's a bit too strong. Yeah. The next thing you'll notice is, if at all I'm supposed to, because at the end of the day, I'll have this map and I'll also have a legend. A legend simply helps the user relate with what's on the map. For example, if I have these lines, what do these lines mean? What do these colors mean? So that's what is supposed to be on a legend. But if I come to my layer manager under interpolation, if I click this plus button, I can see numbers and numbers and numbers and numbers. Now, you might be asking, what do these numbers mean? Or even what do the colors mean? So according to my ramp, this is a color ramp, the colors. according to my RAM, it's showcasing that this shade of blue has the least occurrence of crime, and this shade of almost brown, brown or bordering gray, this shade of dark brown showcases the highest occurrence of crime. Meaning these areas where we have light blue, we're either having low occurrence of, not crime, sorry, low occurrence of hazard events, or remember, or even no hazard event happening. Now, the reason why I'm saying that is because in as much as we're saying that this value is 1, remember, hazard events do not happen everywhere. You can't tell me that once you have this map, it's simply showcasing the light blue areas are showcasing cases where we have 1 hazard event. That's in as much as that's what it's saying, we have used this technique to create a continuous surface. But the interpretation of that light blue color is where we're having either no event happening or a very low count of event happening, of hazard event happening. And then now for the 20 and 21, we have very high cases. So for example, to the very north, to my southeast, we have some centroids where we're having very high cases of crime. Now the next thing is, since once I come up with my legend, I cannot, these values will not be helpful to the user. What I need to do is create a thematic map. A thematic map could be, it simply gives your map, your thematic map simply maps out an event based on a particular theme. In this particular case, let me just show you. I'll just select my interpolation, right click, and then select create thematic map. I do not want mine, you'll notice that for this map, we're having unique values. These are unique values like 4.87, 5.51. What I want is a range such that I'll have a certain range of numbers would be very low, a certain range of numbers would be low, a certain range of numbers would be very high. So that would be, let me just right click and create my thematic map. So we have grid ranges map. So we initially had a unique values map, but I want a range where I'd say like for this range of values, I'd have this very low or something. So I'd select default and select OK. And this is the map that you'd be having, or this is what it would come up with. So to my very left, let me just shut the eye for my initial interpolation. I can also shut the rest, but I'll make sure this remains. Let me just rename this to right click, rename. I can rename that to county boundary. Yeah. Then for interpolation, you'll now notice that we are having sort of like a range. And also to my right, you can see that we can do a bit of tweaking and editing here. Number one, the first thing I want to change is the color. It doesn't look so good. The next thing, I want to see if I can make it more visually appeasing. The third thing is to change the title of what the user will see at the end. So we start with the method. So the method here shows equal interval. Equal interval simply means, like for example here, we're having an equal interval of about, okay, let me first change this section. Let me change my label format to 0 to 100 to make it more clear. If you look at the title, we're having the difference, and even the range. The difference between any range is roughly 3 point something, right? But in as much as, okay, equal interval is good, but the visual representation isn't so good. You're not able to see the stark difference or see how you're moving from areas of low hazard events to areas of high hazard events. So the next thing I could maybe check out is the square root. No, doesn't look so good either. We're having this one looks a bit good. It sort of showcases you and brings the stark difference between someone moving from areas where we have low events happening to high events happening. So this is a logarithmic interval. Now the reason why we're having various techniques and various methods here, like square root and logarithm, like getting the log for a particular column, it's simply because, for example, if you had data sets that were, let's say, 0.01, that had a column value of 0.01 or 0.02, at times using the square root and logarithmic functions would either, in my particular case, using a square root function would maybe be helpful if you're having huge data sets. Like you're having the value would be maybe 25,000, 20,000, or even maybe to 56,000, getting the square root of that. For getting the logs, in short, this particular method simply aid you in visualization. So in my particular case, and in this case, in this project, I chose to go with the logarithmic interval. My range count, remember, from my map, I have the county boundary. I have very low, low, moderate, high, very high.
Alien,
Yes, yes.
do you cannot see the presentation?
You can't. Oh my goodness. Oh my goodness. Oh my goodness.
You
Wait,
cannot see the presentation.
sorry, I don't know what happened. Give me a minute. Mm. Is it now visible?
Yes, it is.
Where did it stop? I'm so sorry. What was the last thing you saw me doing?
You can continue.
Okay. Okay, so I was saying that for I choose to use the logarithmic interval. Then it's important to note that for the number of ranges that I wanted to have from my PowerPoint presentation, I have very low, low, moderate, high, and very high. So I need 5 ranges. So going back to my software, I'll just select the range count to be 5. Yeah. My color scheme, the color I chose to use for this one is under for graph, for the graph maps, this shade. Yeah. Then the next thing is to change my title. The title would simply showcase what you see to the very bottom left. So remember I said we'd have very low. You just double click to edit. Low. I have moderate. I have high. And I have very high. And you see, even as you edit it, you're able to see the changes on the map. So up until this point, I can still save my map. So the next thing is, because I already have my map and I think everything is good to go, the next thing is now to come up with a layout. The layout is simply, after you've done your mapping and everything, it's simply the final end product or the final output that you use for presentation, or like the final end product for the user. So the first thing I'd like to do is delete all these. I won't need them. Just right click and delete. Yes. I have my county boundary, yeah, so everything is good to go. So I'll just save that again. I can close it. The next thing, I have my maps. You'll notice that under maps, I have my map. The next thing is now under layouts. I'll just create a new layout. And with Supermap, you could either choose to work with a blank template. This is how a blank template looks. It's simply blank. You're able to start your mapping, or rather coming up with the adding of your map elements. We have 5 elements mostly. We have the scale, the title, the compass, the legend, what else? The grid. But in this particular case, because I'm just showing you how I came up with the map I created, I used, let me right click, new layout. We have, Supermap also has some templates that you can use. I think the template I used was this one. We have so many. And you even see that for some, you can have as many as 3 maps in one layout. But because I only have one, this is the one I used. You select it, you'll be prompted to select the map that you want to use. I want to use this one. I do not have an overview, so I'll leave that as blank. By an overview, I simply mean it could either be another map. So for areas that are too small to be seen, or to showcase the bigger picture, something of a sort. So I'll create, and this is what I have. Now this is then where your creativity comes out, because in as much as I'll be showing you exactly how I came up with, this final map, it simply depends on exactly what you want to show. So in this particular case, number one, I can choose to modify this name. The minute you click on double click to modify the name, you'll notice that to your right we have a few details. So I want to go to text, double click to modify name. No, I'll input Kenya multi-hazard map. I prefer this font. As I mentioned, this is where your creativity comes in, how well you'd like exactly what you want to be seen. Let's say 25. Okay, Kenya multi-hazard map. I will change, great. I will delete this section. Double click to add attached map. I will delete this section. So just select it, delete, select this one, delete. For this particular case, I could choose to edit it to just select it to the very right. I'll change the fonts. That's too big. For the date, today is 28th. Right. I can choose to move it. Let me move this a bit to the right. Something like that. Okay. The next thing is we also have a bit of text in the middle. This double click to add your map. I also want to delete this part. Oops. Yeah. The next thing is I select my data frame. This is called the data frame. The data frame is what houses the map. So I select my data frame. I want it, I want it moved a bit to the very left. And, this is what I wanted to delete. And because I want my map to be centered, let me first make sure that this aligns well. Let me bring this down. I can delete this, bring this down a bit. So the next thing would be to center my map in the data frame. And how you do that is by selecting the data frame, select focus map. What focus map does, it simply means that all your operations right now will be happening inside the data frame. Then I'll select full extent, which simply means make the map inside the data frame to be in full extent. Then you select focus map again to now get you out of you only focusing in the data frame. So I have this. Next, they already gave me a compass. You can choose to change the compass if you don't like it by select properties. To your very right, you see various styles. So let's say which one? Let's say this one. I can't see it. Where is it? Let me add it again. Select. So how you add various details would be under, by default you're under layouts, but we go to object operations. We have various items here. Now what I'm looking for is for the north arrow. Okay, let me place it here. This is what, let me change the size, move it. inside, something like that, but it's too big. Let me just, yeah, something like that. The next thing, you can choose to change how the scale looks like or leave it as is. No problem, it shouldn't be much of an issue, but I'd like to change the style to be the same font as what I'm using for my map. So as I mentioned, this is simply aesthetics, for aesthetics purposes. You're simply beautifying your map. So there's not much theory to cover here. The next thing is to add a legend. So I have to select my data frame under object operations. You'll notice that if you're trying to add the legend or any other map elements, if you haven't selected the data frame, they're grayed out, you can't select them. So I have to select my data frame, then select legend. I have to specify where I want it to be. I'll just do something like that. Right, so this is it. Doesn't look too good. So what, if you click on the legend, or even if you right click then go to properties, you'll notice that you're right, you have legend properties. Number one, I only need, it's given me 3 columns, I only need 1 column. You'll notice as you're changing, things change also. And once I do that, I'll have to, let me change it a bit. I need to change the style. I need to add the font size. So under font settings, this is where you change the, if you need to change also the legend title, you can change it here. Sometimes people don't add the name legend, so it's okay. So I'd like to change the legend title, the font size to, let's see, 48. Let's say 50. You'll notice it changes, the name of the legend name changes. I'll change my font as well. Yeah. Next is the item style. The item style in this case would be the county boundary. Let's say 48. Let me just set it as 50. I'll change the font name. I'll do the same for the sub item style. This would be the very low, moderate high, and very high. $50 font name. Yeah. So this looks a bit better. Yeah, this looks a bit better. The next thing I'd like to do is add my grid. Maybe you're wondering why I left this section off. The reason why I left this section off is because I needed to add this sort of details about the map. For example, like the data, what the map represents. In this particular case, like hazard events including droughts, flood, forest fires, and whatnot. We have where I got the data from. I've mentioned the humanitarian data exchange. If anyone would like further clarification about the map, they can get me through this email. And then just a few other statistics about the data. So the next thing I want to do is to add my grid. I just select that. That means let me bring this low first. Let me also make sure we have space for my grid values over here. Let me bring this low. Okay, then select grid. So there are various methods that you can choose to display your grid values. My preference is normally the black vertical label, where I'm having my longitude values displayed horizontally and my latitude values displayed vertically. So I'd select that. And you'll notice this is also why we had to make sure that all my data sets were in the same coordinate system. You've realized that automatically it's been able to pick that it's in this coordinate system. The number of rows that I want are not 10, I want 5, roughly 5 for each. Now you can see, no, it doesn't look that good. One, two, three, four, five. 1, 2, 3, 4. This one looks to be 10. Let me change it. How you change your final output, like for the grid, to my very right you can see like we have the layout map properties and then we have the map grid. So let me delete that and start over. I can create another one by selecting the plus to add. It's still not. Where is it? 1, 2, 3. These are columns, rows. Let me change the number of rows to maybe 3. See, it still looks good. Yeah, something like this. This looks better. This looks much better. So if you also need to change perhaps the writing, I prefer no, it's okay. Let me just leave it as is. Let me change for my legend or my, let me bring it down a bit. To the side. Oh. Yeah. So maybe change this a bit as well. Yeah. So this is okay. For my scale, I can maybe even move it to this side or even put it here. Yeah, this is okay. My scale. What I'm simply doing is, for my scale, you'll notice that for whatever element you're adding to your map, you can be able to change their properties and their settings to the right. So that's what I'm currently trying to do with this particular scale. Let me just leave it here for now. The next thing is remember I had a few things I wanted to write to this side. So how you do that is you simply, under the object operations, you simply have the text. Now for the text, I want it to start from, let's say, here. Now, because I already had written what I wanted to display here, so I can just copy paste. I just copy. What I normally say is, because at times you may not know the amount, or rather the size that you'll need for the other attributes or other information. So what I normally say is first have it written down somewhere else. Then once you bring it onto the map, you'll be able to know what you'll be sectioning out. So in this particular case, for example, I have I'll just copy paste this, copy, and once I select my starting, I'll just CV, control CV. So I have this. Now you'll notice that if I choose to leave that as is, you see it's too long because it's picked it up directly from how I had written it. It's way too long, yet I need it to only fit the right side. So what you do there is you start you can actually do it from here, but you start creating breaks. For example, by breaks I mean moving to the next line, because you're trying to then shorten the length of your of the lines. So we have maybe, let's say, hazard events. Perhaps I can look at my initial map. We have hazard. I need it shortened to hazard, fires, landslide, thunderstorms. Hazard. So let me just hazard. Fires, thunderstorms, and windstorms. Okay. The next thing would be provided events, done events in. So provided events, we have a space there. Events, this was provided events, done events, provided events. You see, it's already shortening itself. So provided events, done events in. Yeah, it should make more sense. Yeah, it sort of makes more sense. So what you simply need to do is, okay, but this is too long. Let me change that from mudslides. Let me just, yeah, something like that. Yeah, something like that. So the next thing I need to do is, okay, let me make sure I go saving my work as we move so that I don't lose anything. I need to save this as 02. Yeah. I just need to select that, then move it to where I need it to be. I need it to be to my very right, something like that. I also need to change the properties. I need to change the font size and maybe the font style. Maybe set this to 16. Let me set it to 18. 17. Yeah. Something like that. Something like that. Okay. What else is needed? Another thing is I chose to add sort of like a table showcasing the hazard events, but this is purely up to you. You can choose to leave it out or not. What you're noticing, what I'm simply trying to tell you is, in as much as for map creation, there has to be a methodology that you're following and why you're choosing to do this step and whatnot. For a map, I mean, for the layout, this is simply based off on aesthetics, like how well do you want it presented. Of course, a map should have good representation once you've already added the other elements of the map, but what else do you need to be shown? That's simply what I'm showing you. So the next thing would be maybe to add a table. I know I've been talking for so long. The next thing would be maybe to add a table. You can select it, the area for the table, and once that happens, it should actually show you something like this should pop up. This is where you'll be coming up. I won't do it now in the interest of time, but this is where you can choose to. For me, I think I chose to look at hazard and then the percentage. So you can just type out, for example, hazard, and then the percentage. You can choose to use percentage, or maybe someone else would want to look at count. This particular section is simply to show you or to give the user more information about the dataset that you used. So it's not mandatory. As I mentioned, it's simply what you as the author of the map would like to do. So I won't write everything, but let me see. So and then we have like all your details that are there. For example, I have for flood, for drought, for epidemic, any epidemic, for extreme rains, and any other data sets or any other events and whatnot. Once you're done, you select that tick, go back to your map, and this is where everything should be. Now, of course, it seems to be out of proportion. I'll have to. Maybe it's because I just wrote one. But ideally, you can see that that's how you come up with the final layout. Now, how to export this? Okay, once you've already saved everything, you can then choose to export this layout. How you do that is under layouts, export to picture, or export to PDF if that's what you'd like. I'd choose to save it as 02. I make sure that the location of where I want it saved to is okay. I want it saved under layout. The resolution I prefer using is 600. It's very clear. By default, we normally use 300, but I prefer 600. It's very clear. It takes up a bit of more space, but it's very clear. So I can go to here. We can see it's been taken, exported successfully. I can go to my file explorer to see that. And under layout, I should see it. Yeah, here it is. Let's view that. And this is how it is. Looking at the map, first of all, I can notice that the Kenya multi-hazard map seems to be cut a bit. That means I'll have to go back to the software, maybe reduce the font size, or maybe bring it down a bit. I think I could maybe change the scale, but ideally, this is the multi-hazard project that I was planning on taking you guys through, right from the theory of GIS behind it to the creation of the map, and then finally to like having the final layout. You can choose to be innovative and come up with, just experiment with the layout. Maybe your final map could be different than mine, which is still fine. Yeah, I will also, so I can now stop sharing, but I will also be sharing I think I shared it with Rita, the tutorial for coming up with this mini project, right from data collection. It's very detailed. So in as much as maybe I might have lost you along the way,